Introduction to Satellite Communication, presented by Amir Chetri. What is satellite? A satellite is a solid object which moves around some heavenly body due to effect of gravitational force which are mutually in nature. The first satellite that was used for communication purpose in India was Aryabhatta, and it was launched in 19 April 1975. It was made and assembled by an organization called Indian Space Research Organization (ISRO). In the year 1981, a satellite named Apple was launched in space, which was the first Indian experimental communication satellite. There are thousands of man-made satellites. Some take pictures of our planet, some take the sun and other objects. This picture helps scientists learn about Earth, the solar system and the universe. Other satellites send TV signal and phone cell around the world. Why are satellites important? Satellites fly high in the sky so they can see large areas of Earth at one time. Satellites also have a clean view of Satellites also have a clear view of space. That's because they have above Earth's cloud and air. Before satellite, TV signal didn't go very far. TV signal only travel in a straight line, so they would go off into space instead of following Earth curve. Sometimes they would be blocked by mountains or tall buildings. Phone sale of phone sales to faraway places were also a problem. It cost a lot and it is hard to set up telephone wireless over long distance or underwater. About satellite communication system. A communication satellite is an artificial satellite that relays and amplifies radio telecommunication signal via transponders. It creates communication channel between a source, transmitter and a receiver at different locations on Earth. Communication satellites are used to television, telephone, radio, internet and military application. Here, the ground equipment transmits signal to the satellite and the satellite amplifies the incoming signal and changes the frequency. Signal is transmitted back to Earth and the ground equipment receives the signal. Satellite, active satellite and passive satellite. Passive satellites, natural and artificial. Active satellite. Active satellites are complicated structure having a processing equipment called transponder which is very vital for functioning of the satellite. This transponder serves dual purpose, provides amplification of the incoming signal and performs the frequency translator of the incoming signal to avoid interface between the two signals. The active satellite has many benefits over passive satellite. It has its own transmitting and receiving antennas. It amplifies the signal receiver from earth station or ground station and retransmit the amplified signal back to earth. In addition to amplification, it performs frequency translator to the received signal before retransmission. Active satellite can generate power for its own operation. It is known as active repeater due to its functionality. Passive satellite. Passive satellite are relay station in space. Passive satellite can be further subdivided into two types, namely natural satellite and artificial satellite. A moon is a natural satellite of Earth, but spherical balloon with a metal coated plastic serve as artificial satellite. The passive satellite is a reflector which receives the signal from the transmitting earth station and scatters the signal in all the directions. It reflects the EM radiation without any modification and or amplification. Passive satellite cannot generate power of its own and simply reflect the incident power. It is known as passive repeater due to its functionality. History of Keplers. Johann Kepler was a German astronomer and mathematician of the late 16th and early 17th centuries. His work was largely based on the work of his mentor Tycho Brahe, Kepler was able to use Brahe's precise measurement made before telescope to determine the mostly by trial and error. Three laws that describe the motion of the five planets that then known. Three laws of planetary motion, laws of orbit, laws of areas, law of time period. Law of orbit. The orbit of planet comes about the Sun in elliptical with the Sun's center of mass at one focus. This is the equation for an ellipse: x square by a square plus y square by b square equal to 1. Laws of area. A line joining a planet, comet, and the Sun sweeps out equal areas in the equal interval of time. This equivalent law discovered by Kepler arises from conservation of angular moment. Thus, a planet executes elliptical motion with constantly changing angular speed as it moves about its orbit. Law of time period. The squares of the period of the planet are proportional to the cubes of their semi-major axis. T, T a square by tv square equal to ra cube by rb cube. Kepler's third law implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. Thus we find Mercury, the innermost planet, takes only 88 days to orbit the Sun, but the outermost planet required 248 years to do the same. The law of period describes the relationship between the average distance of a planet from the Sun and the orbital period of the planet. Thank you.